Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll start with a new concept in expectation of probability, and the topic for today's lecture will be probability generating function. Probability generating function is used only when the variable that we have is a discrete variable. It is also denoted by PGF. So this is our probability generating function. Now, if we have a variable x, which is a discrete random variable, then probability generating function of x can be denoted as px, which is equals to expectation of s raised to the power x, which is nothing but summation over x. X goes from 0 to infinity, s raised to the power x into px, where px is the PMF of this random variable. And here we can also say that if we put s equals to 1, then it will be summation over x goes from 0 to infinity, s raised to the power 1, 1 raised to the power x into px, which is the probability. Now 1 raised to the power x is nothing but 1 only, and summation go from x to infinity, probability is always equals to 1. So this becomes one of the properties of probability generating function, that when we keep s equals to 1, then it always comes out equal to 1. Then if we have to check whether certain function is a probability generating function or not, then we can use this property for calculating. Now moving forward to some of the properties of PGF. Properties. So the property states that if we calculate p raised to the power r 0, then it will be nothing but modulus of d raised to the power r d sr ps at s is to equals to 0. When we have to calculate the RH probability at s equals to 0, then this is the formula, differentiation formula. And if we keep s equals to e raised to the power t, then ps, which is probability generating function, becomes mxt, means probability generating function becomes MGF, moment generating function, when we keep s equals to e raised to the power t. Now moving forward, we know that the third property is, we know that px is nothing but 1 minus qx, right? This we know that when the probability of success is equals to 1 minus probability of failure. Now if we know that px is also equal to probability that x is less than equal to, let us say, a variable k, so qx will be equal to probability x is greater than k, right? So here we can replace them by putting equal to px, ps is equals to summation over x, x raised to the power sx into px. and qx can be written as summation over x sx qx, right? This is the probability generating function. Now we can also write this as qx is equals to 1 minus ps upon 1 minus s. This is one of the formula for calculating our probability generating function of a failure of a random variable. And one more property is there, that if we have to prove that two variables x and y are independent. Suppose it has been given us that p x comma y s1 comma s2 is equals to p x s1 into p y s2, then only we can say that x and y are independent. If we have to prove that two variables, two discrete random variables are independent, that we have to prove it by this property. So now moving forward to some questions that we have taken for today's class on PGF. PGF is PGF is a very low coming has a very low probability of coming in your examination, but has at least can come. We don't know the concept of exams, and we cannot predict that. So we have to do all the topics. So talking about this question, they have provided us with that if we have a random variable x, then it has PGF as the for random variable x, PGF is equals to PXS, and we have to calculate the PGF of 2x plus 3. Now we know the formula. PGF of 2x plus 3 is equals to summation over x s raised to the power 2x plus 3 into px 2x plus 3. Now we can solve it by taking s raised to the power, or we can say that this is nothing but ps only, px. So we can say that this is probability of p2x plus 3. Now instead of writing it 2x plus 3, we can write it as probability of x s 2x into s cube, right? We can take s cube outside and we can write it as px s raised to s square, and we can take x outside. So this is our final answer, which forms our probability generating function, and this matches with our the option number A, which is s cube px s square. That is our final answer. This is how we calculate. It is an easier concept. Now moving forward to another question. Here we have been provided with two lists. One is the random variable and the other forms the PGF, and we have to match them. So how to attempt these kind of questions? See, A has only two options, 1 and 4, and D has rest other B also has 2 and 3. C has 2, 3 and 4. D has 1, 2 and 4. So we'll check for A. First of all, A is given as x plus 1. If we have to calculate for x plus 1, Px s plus 1 can be written as s raised to the power x plus 1, which can be written as px s into s raised to the power x, which can also be written as s px s raised to the power x. So x plus 1 has this PGF, which is s into px, which is our option number 1. So A has the A is equals to option number 1. Now here we have three options as A option number 1. So B is cancelled. Next, we'll check about b because it also has two variables. So if we check about b, if we are talking about 2x, then px s raised to the power 2x can be written as px s square, which we have done right now also. So 3 b has option number 3. Now these two can be the option because it has b as 2. So this cannot be our option. C and D must be one of the option. So B is matching with C option. Now if we have to calculate P is less than equal to N, probability X is less than equal to N, then this is nothing but, when we say probability is less than equal to N, then we are talking about Qx. Or let us say it is not Qx, it is Qn. And if we can also say that if P is less than equal to n minus 1, then we can take it as Qn minus 1. Then if we subtract Qn minus 1, then this will be equal to R P X. Right? Now, instead of Qn and Qn minus 1, we can write it as summation over Qs raised to the power. If we put summation over n raised to n goes from 0 to infinity, Qn s raised to the power n minus summation over n goes from 0 to infinity, Qn s raised to the power n is equals to summation s raised to the power n goes from 0 to infinity, Pn. Right? So here we'll be getting Qs minus Sqs is equals to Ps. And if we take Qs common, we'll be getting Qs equals to Ps upon 1 minus S, which matches our option number 2. C matches which are option number 2, and hence C, our option number C is correct, where A is 1, B is 3, C is 2, and the one which is left is 4, D4. That's how you calculate for PGF. Now moving forward to another question. Here this question, they have given us the probability generating function of a non-negative integer value random variable x as ps, and then they have asked us to calculate this. Now we know that p of s square, if we calculate this comes nothing but equal to what? Probability of s square, now or only we have calculated, this is equals to 2x when the random variable is 2x, right? So when random variable is equals to 2x, then only this probability comes. Now if we integrate this, we can write p s square as equals to summation over s raised to the power 2x into px, right? X goes from 0 to infinity. Now if we put this in integration, they have given us 0 to 1 PGF s square ds is equals to, if we put it in integration 0 to 1 summation over x goes from 0 to infinity s raised to the power 2x px and whole bracket ds, right? So we can take summation outside. Summation x goes from 0 to infinity. Since the differentiation integration is for s, so we can take p x also outside and we can integrate the rest, which is s raised to the power 2x ds. Now s raised to the power 2x ds has integration summation x goes from 0 to infinity px s raised to the power 2x plus 1 upon 2x plus 1 with the limits 0 and 1. of, these are the limits for s, not x, because our integration was with respect to s. So if we put 1 in place of s, it will be 1. And if we put 0 in place of it, it will be 0. So it will be 1 minus 0, and the denominator will be 1 upon 2x. So it will be equal to summation over x goes from 0 to infinity 1 upon 2x plus 1 ps. If we calculate, now see the formula for PGF. If we calculate PGF for S, then it will be equal to summation x goes from 0 to infinity s raised to the power x p x, or in bracket we can write px. Now here you can see that summation x s raised to the 1 upon 2x raised 2x plus 1 into px. So it will be our estimation of 1 upon 2x, means s is equals to 1 upon 2x plus 1. And hence our option, this can be also written as expectation of 1 upon 2x plus 1. Since the value of x is 1 here, so we are assuming that it will be 1 upon 2x plus 1, which is our option number D. This is how we calculate PGFs in your examination, and this can be one of the topic that can come this year because it hasn't been asked more frequently in the recent years. So it this makes it a higher probability to come. Now moving forward to another kind of question. This is a simple expectation question, not of PGF, but I thought it would be useful for us to calculate it. So they have provided us a random variable and they have given us two values. So they have given us expectation of x minus 1 whole square is equals to 10, and they have given us second expectation of x minus 2 whole square is equals to 6, and we have to calculate the variance. Now first of all, let us calculate the variance. Let us solve these. Now if we put the square, it will be expectation of x square plus 1 minus 2x is equals to 10. Expectation of x square plus expectation of a constant is a constant itself minus 2 expectation of x is equals to 10. Now let us calculate for this as well. It will be expectation of x square plus 4 minus 4x is equals to 6. Expectation of x square plus expectation of a constant is a constant minus 4 into expectation of x is equals to 6. Now since both the terms are coming in expectation, let us consider expectation of x square is equals to y and expectation of x is equals to z. So putting that, y plus 4 minus 4z is equals to 6, and we can also keep it as y minus 4z comes out to be 2. Let us keep this as equation number 1. And here if we put y plus 1 minus 2z is equals to 10, y minus 2z is equals to 9, which forms our equation number 2. And on solving equation 1 and 2, we'll be getting y equals to 7 upon 2 and z equals to 7 upon 2 and 16. Let me see it. Yes, and z comes out to be, these are interchanged. Z comes out to be 7 upon 2 and y comes out to be 16. You can check it. I'm just writing the direct answer so as not to waste our times. So this is how y and z are coming. Now we know that they have asked us the variance of x. We know that variance of x has formula expectation of x square minus expectation of x whole square. This is our formula for variance. keeping the value, this is nothing but expectation of x square we have taken y minus expectation of x is z, so it will be z square. So it will be 16 minus 49 upon 4. If we subtract it, we'll be getting 15 upon 4 as our answer, which forms our option number B. So these kind of question can also be asked. When you will know the formula, you'll be able to solve it within a minute or so. Practice will make you perfect in this. So this was all for probability generating function and expectation. Now our expectation has ended. We'll be starting with a new topic in the next lecture. Till then, keep on revising and keep on doing whatever you're focusing on. Keep your focus towards one particular goal only. And if you are facing any doubt, then you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.